Your drinking water, whether it comes from a river, lake, stream, spring or groundwater, is at risk of being unsafe. What makes water safe is the care and consideration you and others have for activities and actions in the catchment, the treatment, and in the storage and distribution of the water. This video follows on from the Blueprint for Safe Drinking Water video, which provided an introduction to risk management planning. In this video, we will look at putting together the basics to create a public health risk management plan for your small water supply. Experiencing the consequences of unsafe water yourself is one way to learn what activities and actions are acceptable, but not recommended when it puts people's health at risk. To help identify the activities and actions that could affect your drinking water supply, this video provides examples that have or could cause problems for small water supplies in New Zealand and the solutions to those problems. This is the starting point in preparing a safe drinking water plan for your supply. A public health risk management plan covers the questions: what could cause the water quality to deteriorate and become unsafe to drink? Which of these need urgent attention? Urgent attention is needed for something that happens a lot and or could cause significant illness. Other questions the plan covers are how to know when the water quality is deteriorating to a point where action is needed, how to respond if the action is needed, what to do to stop this happening in the future. So, how do you prepare the plan? This guide will take you through a 3-step process following these questions to prepare your supplies public health risk management plan. Step 1 is a simple drawing of your water supply. It highlights the major flows and influences. Step 2 mirrors the drawing, one worksheet for each of the 3 aspects of the supply: catchment and intake, treatment, and storage and distribution. The result of these worksheets is identification of what needs urgent attention, which, remember, are the events which are of the most concern. Step 3 focuses on the issues that need urgent attention and develops a plan to manage these. The plan covers both immediate responses and a longer-term improvement schedule, including identifying the resources you need. Let's start at looking at step 1. Every small water supply is different. Therefore, a simple drawing or flow chart of your supply is important. You need to start from the beginning of your supply. This is the catchment and intake area, which is the water source for your supply. Your water source could be surface water, groundwater, or rainwater, and it is important to be familiar with this area of your system as it influences the rest of the process. From here, the water will most likely follow through to the treatment area of your supply. At this point, the water is finally transferred to the storage and distribution area. All supplies are different, so take a moment to think about your supply before creating the drawing. Your drawing should be simple, and it is important that you highlight the major flows and influences. Once your flow chart is done, you need to start developing your plan. First, you need to look at catchment and intake. In the worksheet, there are 3 columns which need to be filled out. First is a note of what could happen to make water unsafe through deterioration in water quality. Secondly, you need to decide whether this is under control, and if it is, state how it is under control. And thirdly, if it is not under control, you need to judge whether this issue needs urgent attention. Let's look at an example. At this spring, there is extensive vegetation surrounding the spring that could contaminate the water supply. Dirt and weeds carrying disease-causing organisms that could enter the supply and really deteriorate the water. Overhanging vegetation is more of a problem for rainwater supplies, providing access to the roof for vermin like possums. Let's add that to our worksheet as a cause that could make the water unsafe. Extensive vegetation around the spring. Now, is this issue under control? In this case, yes, as the vegetation is now being cut back once a month. If we go back to the same water supply, we notice that the spring is at a low point in the gully, susceptible to contamination of carrying disease-causing organisms from surface runoff, especially after rain and during drawdown. So let's add that to our worksheet. The spring is at a low point. Now, this example is not under control, as this issue is happening regularly, every time it rains, and potentially causing contamination to the water supply. Therefore, this issue is needing urgent attention, and the box is ticked. We will come back to this issue in our plan to manage the system. In the catchment and intake worksheet, you also need to consider such issues as natural events, such as slips and earthquakes. How about farming practices? Animal droppings or even dead animals are a major issue when close to a water intake. These are major reservoirs of disease organisms such as Campylobacter, Cryptosporidium and Giardia. Here we can see cow droppings next to an open well. This catchment area is not fenced off, allowing animals to get too close. Disease-causing organisms from the droppings can be flushed into the ground near the well, causing contamination of the supply. Let's add this to our worksheet. Stock have direct access to the area close to the well. This issue is not under control, so we again tick the needs urgent attention box, and we will come back to this situation in our plan to manage the system. There are also people issues. Here there is a campsite right next to an open well. Remember, add your own reminders. Every water supply is different, so it is important you learn to recognise risks with your own supply. Some supplies may have many potential risks, while others may have only a few. You may need to use a few worksheets to fill in the risks for some sections. Your catchment and intake worksheet is now complete. You may want to pause the video at this stage and look at your own worksheet to make sure you understand it. The next worksheet is treatment. As you can see, as in the catchment and intake worksheet, there are the same 3 columns which need to be filled out. The first is, of course, a note of what could happen to make the water unsafe. Let's have a look at an example, a UV system. Here, if there was a power cut, the water would not be treated, yet will still be sent to many homes and could cause major illness in the community. So let's add that to our worksheet as a cause that could make the water unsafe. UV system fails due to power cut. Is this under control? In this case, there is a standby generator ready to go in case power fails. So yes, the issue is under control. Now in this case, we have a bypass system in place to allow for maintenance of the filter. However, when this bypass is in use, untreated water enters the distribution system and water will be sent to homes untreated. This is then unsafe, and let's add that to our worksheet. Untreated water enters the distribution system through the bypass during filter maintenance. Now, is this issue under control? No, as the water will always bypass the filter during maintenance, and the unsafe water will then enter the distribution system. Therefore, this issue needs urgent attention. Again, we will come back to this issue in our plan to manage the system. In the treatment worksheet, you need to consider such issues as operator knowledge and making sure the operation of the treatment is done right and proper. The pump itself could fail. This can cause many problems such as backflow. Even system maintenance. Rusty and leaky pipes can cause contamination of the water, therefore making the water unsafe. Or a ruptured or blocked filter. Remember, add your own reminders. Every treatment plant is different, so it is important you learn to recognise risks with your own supply. Your treatment worksheet is now complete. You may want to pause the video at this stage and look at your own worksheet to make sure you understand it. The next worksheet is storage and distribution. As you can see again, there are the same 3 columns as the previous worksheets, which need to be filled out. The first column is of course what could happen to make the water unsafe. Vandalism of storage tanks is of major concern. Here the tanks are locked behind a secure gate and a high fence is in place. The tanks are secure and could not be vandalised. Let's add vandalism to our worksheet as a concern. Vandalism of storage tank. Now in this case, this issue is under control as the location is secure with a fence and a locked gate. So let's have a look at another example. Here in a very long distribution through a rural area, events such as a backflow from a property storage tank, farm chemical mixing tank or a stock trough could cause contamination. Backflow is the sucking or pulling of contaminated water back into the pipes caused by a drop in pressure because of something like a break in the pipe or failure of a pump or heavy draw-off. This would then result in unsafe water for many homes. Now let's add that to our worksheet. Recontamination from backflow. This is not under control and contamination could happen at any time backflow occurs. Therefore, this needs urgent attention. Again, we will come back to this in our plan to manage the system. Other issues to consider in the storage and distribution worksheet are rupture of tanks or pipes causing contamination. The state of reticulation to and from storage areas. Reticulation must always be maintained to avoid contamination. Condition of freestanding tanks. And also the condition of tank lids, making sure the lid is tight and secure. Here we can see a securely designed tank lid. The raised lip that the lid fits and an overhanging lid stops rainwater from washing contamination across the top of the tank and down through the lid opening into the tank. The lid is also padlocked to stop vandals. Remember to add your own examples. Every storage and distribution area is different and will have different causes of contamination. Your storage and distribution worksheet is now complete. You may want to pause the video at this stage and look at your own worksheet to make sure you understand it. This also completes step 2. The final step in your public health risk management plan is to complete the plan to manage the issues that need urgent attention. These were highlighted earlier in the previous worksheets. The plan sheet consists of 4 columns, all of which need to be completed. The first is again a note of what needs urgent attention, copied from the previous worksheets. The second column is an improvement schedule. It asks you to explain how you can remove or remedy the issue and by when. The permanent fix. It also asks you to identify help and resources that you do not have or cannot afford. The third column asks that until remedied, how will you know when these urgent attention issues are actually causing deterioration towards unsafe drinking water? The fourth and final column asks what contingency management plan is in place until these urgent attention issues are fixed. Let's go back to what needs urgent attention. When we looked at our catchment and intake, one issue we discovered was the spring was at a low point in the gully and was susceptible to contamination from surface runoff. We can add this to our plan to manage the system. When we looked at the treatment plant, we discovered an issue that needs urgent attention when during maintenance untreated water would bypass the filter. We can add this to our plan to manage the system. Finally, when we looked at our storage and distribution area, we discovered an issue that needed urgent attention where backflow could cause contamination. We can add this to our plan to manage the system. For this video, we are going to focus on only one or two of the issues that need urgent attention and explain how to manage this issue. So we will focus on catchment and intake, where the spring was at a low point. So how could the surface runoff from the gully be remedied? The wellhead could be reconstructed. The concrete apron should be sloped to drain water away from the well, and a ditch dug around the concrete apron to intercept and redirect surface runoff away from the well casing. The well casing should be extended above ground level. This design could vary to suit and resolve different issues in the catchment. We can add this remedy to our worksheet. But until this is remedied, how will you know when this is actually causing deterioration towards unsafe drinking water? As surface water runoff occurs during heavy rain, this is when the problem arises. Therefore, you know when you need to deal with the problem. So what contingency is in place until the wellhead is reconstructed? Water would not be pumped from the well during or immediately after heavy rain, but runoff could still enter the well. So after heavy rain, when water is pumped, a standby chlorination system could be used, or all consumers need to be notified to boil the water. Which reminds us, you should take note here in this column of the form, who needs to know that the contingency action is being used. In this case, the consumers, as soon as possible. Our second issue from this worksheet. Stock have direct access to the area close to the well, can also be dealt with by returning to our reconstructed wellhead. It would be a good idea to fence off the catchment area to prevent problems with farm animals, as we saw before, with the cow leaving drop-ins near the open well. Also, a shed like this one could be built around the wellhead to stop any unwanted interference. We can add this remedy to our worksheet. By covering what needs urgent attention for the catchment and intake, we have now completed this risk of contamination effectively in the short term, and plans are in place for long-term improvement. Covering what needs urgent attention for the treatment and also the storage and distribution issues will follow the same management process we have just carried out. You may find that the solution to your issue requires resources you do not have or cannot afford. The Ministry of Health is aware of this and would like to provide assistance. Please contact your drinking water assessor for details on assistance for your water supply. Once these sheets are completed and the plans to manage the issues of contamination are finalised, your public health risk management plan is complete. But what do you do with the plan? Your plans need to be checked over by a drinking water assessor. Your public health risk management plan will guide both your day-to-day actions and your long-term planning. It will identify regular monitoring and inspections that signal deteriorating water quality and prompt your action. It will identify regular ongoing maintenance to reduce the chance of contamination. It will list where to get help on drinking water quality and how quickly they need to know. It will provide direction for improvements and expenditure. Your public health risk management plan should be reviewed annually after any significant change to your water supply and in response to finding a weakness in your plan. So now that you have worked out how you will manage risks when they occur, how do you know whether your plan is working? The Drinking Water Standards for New Zealand tell you what's required to check whether your supply is safe or not. The standards should be used as a yardstick to judge your water supply by. You should be able to demonstrate that your public health risk management plan is up to date and has been followed. And some water quality testing for indications of disease-causing organisms is required. You should talk to your local environmental health officer, health protection officer, or drinking water assessor about how to collect the water samples and where to send them for testing. Now you, your family, and the greater community can benefit from great tasting, clear and safe water. If you would like further information on what you have just seen, please contact your environmental health officer at your local council, or alternatively, contact your health protection officer or drinking water assessor through your district health board.